Okay, so here we go. Let's talk. Let's review the rules for before we start adding and subtracting rational algebraic expressions. Let's review the rules for adding and subtracting numerical fractions. So I think you guys know this already. If you have a common denominator, perform the addition and or the subtraction, because sometimes you might have a three-part fraction. And then eliminate addition or subtraction in the numerator, and you leave the denominator obviously the same, right? Because you got 5 parts of 7 plus 6 parts of 7. What do we have? 11 parts. So we have more than a whole, right? So we have 1 and 4 sevens there, right? We have 7 parts of 11. We subtract 4 parts of 11. We have what? 11, right? Okay. Now, when your denominators are different, right, you need to convert all fractions using, and I'll talk about what I mean by multiplying by 1. You need to convert all fractions so that all denominators have the least common multiple of all the denominators being added and subtracted in the problem, okay? AKA also known as least common denominator. So, I just did one arithmetic problem here. So 4/5 plus 1/2 minus 1/4. So first thing we need to consider, what is the least common multiple? Yeah. What's the smallest number that 5, 2, and 4 multiply and arrive at the same number? 20, right? Okay. So I can. So we've got 4/5 plus 1/2 minus 1/4. So this is what I mean by multiplying by 1, right? Multiplying by 1 doesn't change the value of anything. So what do I want to multiply? What version of 1 do I want to use for 4/5? I need to get up, 4 over 4, right? I need to get up to 20 here, right? So I'm going to multiply 1/2 by
10 over 10.
All right, and then what do I want to multiply?
5
over 5, okay? So once you can, that's the hard part. And that's exactly what we're going to be doing when we add and subtract fractions, all right? The key is it's a lot harder to identify what your least common multiple is. So this is what? 16/20ths, right? Plus 10/20ths minus 5/20ths, right? Oops. And what's our outcome there?
21.
Okay. All right. So that's just, reviewing the rules. We're going to apply the same rules. Now, a little review. This is the, again, if you need more practice at this, then, there's some problems in the textbook. You could do the odd problems if you were having any trouble. I didn't assign any of these. But let's see if we can remember how this works. Now you got to consider, now we don't know what x is, right? But for example, what is my least common multiple of 3 and x?
3x.
3x, right? Now, I want you to think of this like, what if this was a 7 and this was a 7 squared, right? What would be the least common multiple of 7 and 7 squared? 7 squared. It's 7, 49 is the 7th multiple of 7. And the first multiple of 49, right? So these two are relatively prime. These aren't relatively prime. They share a common factor of x. The powers will pick the highest power, right? So what is the least common multiple of 3x and x squared?
3x squared.
Are you okay on that? All right. Now, so just like x and x squared, it was x squared. What's the least common multiple of x plus 1? X plus 1 squared.
X plus 1 squared.
X plus 1 squared. So then and the 2 is relatively prime to both of those, so we need to bring it as part of the multiple, right? Mm-hmm. For example, if this were 2, and this were, let's say this was x was 4, right? So you have, what would you have here if x was 4? You have 2, 5, and 25, right? Wouldn't you? So what's the least common multiple?
50.
50. It's 2 times all of this, right? Because this is already covered in this, right? So your least common multiple here is what? 2
That's
x plus 1 squared. So just like, is that clear? So we apply the same rules to numbers that we do, to algebra that we do to numbers. Now, these are relatively prime. Everybody know what I mean by that? They don't share any common factors other than 1, right? Now, what do you think we need to do before we consider our LCD?
Factor 3.
Factor of 3. So now, which 2 pairs are not relatively prime?
The last 2.
Yeah, this is not, they share a common factor of what?
3.
3, okay? So, anybody want to take a guess as to what somebody besides Ethan, you seem like totally on top of this. What is your LCM of all this? What's the, first of all, you want to think, what's the least common multiple of -2 and 3? -6. And then we got x and y, right? And then what else do we have to include? We have this 3 covered? Yeah, this 3 is in that -6, okay? What do we have left?
X plus 2.
X plus 2.
Why not 3?
The 3 is included in the 6. It's anytime you share factors, you don't need to include it twice. It's like saying, what is the least common multiple of 3 and -6? -6. You're always going to include the negative. What's the least common multiple of -4 and 8? -8. Because you got that? Least common multiple of -10 and 5. -10. Least common multiple of 5, -10, and 20. -20, right? Okay? All right, last one. So what do you think I need to do to this before I can consider it? Factor it. So factors of -8 and some of -7. Oh, sorry, x minus 8, right? It's x minus 8, x plus 1. So, both of these are already accounted for right here, right?
Yeah.
So what's my least common multiple?
X plus 1 and x minus 8.
Right, okay. This would be like if you had 2, 3, and 2 times 3, right? It'd be 6, right? Okay, so that's going to be a very important skill. That's the hardest thing about all this, is can we identify our least common denominators when we start. Now in the beginning though, you have algebraic fractions where the denominators are the same, so you don't have to worry about this stuff just yet, okay? You'll get there. For now, you just got to learn to add and subtract when we have like denominators. So my denominator is the same. What are we going to do here?
Add 2x.
So that's 2x plus 2x. 4x squared. That's a multiplier. Right? This means 2 of x plus 2 more of x, right? Now if I had 2x times 2x, it'd be 4x squared, right? Any common factors? Any common factors?
No.
No. Okay. Now, I just got to put all my numerators here together, right? Combine the like terms for the numerators here.
5x plus 2.
5x plus 2. Any common factors here? No, it's not. If it was multiplied, then we would. But x is not a factor of this, and it's not a factor of that. Okay. All right. Let's look at some subtraction. 9y. What are we going to do with 9y and 6y?
3y.
So that's 3y over 3x. Any more common factors?
3 is
Okay, so final answer. Now, this is the first problem where things just like get a little bit tricky. This negative applies to the entire numerator. Okay? This subtraction doesn't just apply to this x, it applies to the x plus 2. So, what I'm going to have here is 2x minus 1 minus x minus 2. You must give that subtraction to everything in the numerator. You must distribute it to the x and the positive 2.
Wait, so
Three X
why would you take away the
minus
other plus then?
I didn't take away the plus, I am subtracting, all of this, right?
Oh, yeah.
So I've got to give the negative to both items. It's like if you were adding up all the money you were spending, like I'm gonna buy a soda, I'm gonna buy some popcorn, and I'm gonna buy a movie ticket. I'm adding up all of my costs. Now I need to subtract them from what I have. So I subtract all of the positive amounts from what I started. So you're subtracting, you can't just subtract the x. It doesn't say minus the x, but don't subtract the 2. It doesn't say that, does it?
I didn't see the minus in the middle.
Yeah, that's the key. All right, so what's our final answer here?
1.
Okay, so I get,
X plus 1 is 1.
right, I get x minus 3 over x minus 3. That's one of these rare occasions, but since it's the same thing, the numerator and denominator, you're right, I can make that 1.
So what happened to the other x minus 3?
It's fractions, right? Yeah, it's fractions. It's parts of it's 2x minus 1 of x minus 3, right? Minus x plus 1 of x minus 3. It's like, you gotta get used to having algebraic denominators, but they're still just like they were in numbers, right? Remember back, that's why I showed you at the very beginning, where you don't do anything to the denominators. When I say 11's, 4, what I have. 7 11ths minus 4 11ths, right? That'd be like saying what happened to the second 11, right? Okay. All right, so, all right, same denominator. Now, this negative has got to apply to everything up here. Now, one thing we could do on this, just to make sure that happens, is if I make this 2 negative, that will account for this subtraction. So one suggestion I might have when you see this situation is change this to a plus, make this a negative, and that will make sure everything gets, don't change the sign of that. The negative 2 will have that effect of subtracting everything we want to subtract. All right, we can, I'll just leave that alone for a second. So what I did was I changed all the subtraction to adding a negative, right? So I have x plus 1, I'll make this one big numerator now. What's next? Negative 2x.
Plus 6.
Right.
That'll be 3x plus 3.
Yep. Okay. Caleb, you want to stay with us? Where'd you go? Yeah. Okay, so help us out here. Thought it was a nice place. Okay. I love how I just admitted it. I zoned out. He was melting the pen. The pen is like melting right here. Yeah, he was just staring at it.
I was scared of the board.
You were?
Yeah, I was on the board.
Okay. All right. So what's this going to be here? X, negative 2x, and 3x. What's all that equal?
0.
No. 2x, right? 1, 6, and 3. Yeah. Right over x minus 2. Now you could factor on a 2, but it really wouldn't help you there, so we'll just leave it. Okay? Get into that one. All right, first problem we have where we have a non-common denominator with algebra, right? Okay, what is my LCD right here?
6x.
6x, okay? So, let's write x plus 2 over 2x plus, I'll make some room here, x minus 1 over 3x. What am I going to multiply?
3, yeah.
Yeah, that's the version of 1. There's your multiply by 1, right?
Just,
And this by
just
2 over 2, right? Jennifer, do we need less?
No, my contacts broke this morning.
Oh, they look like reading less.
Yeah.
You look very intellectual today, so you
What?
look very intellectual today.
okay.
Katie always does.
Wait, do you have any disposal for the day? Do you have any ones that you're collecting?
Yeah, it's 11.
Oh, that's, oh,
Okay, all right, here we go. So what am I going to do? So the big denominator of 6x, right? So let's go ahead and throw some parentheses here. So what's this numerator going to look like?
3x plus 6.
3x plus 6 plus,
minus 3.
all right? How do we simplify down here?
5x
5x minus 4.
plus 4.
Any more common factors? Not x. Okay? Let's get to the problem up here. Understand that?
There's my name.
Right.
Okay.
Oh, I was
I won't move it up too fast here. All right. Let's always make our first task. What's our LCD?
Negative x plus 2 x plus negative.
Everybody agree? Without more information, we have to conclude that's our LCD, the two numbers there, so they're relatively prime, right?
Yeah.
So, all right, so let's just rewrite it here. Let's keep the same scheme here. 2x over x plus 2 plus. All right, so what am I going to put in here?
Wait, so is it the?
What am I about to put in here?
X minus 3.
Start throwing parentheses around there. And what am I going to put here? All right, so denominator I can just write now. I'm gonna write the denominator.
X plus 2.
All right. So let's start by distributing 2x to x minus 3.
2x squared minus 6x.
Plus, now I gotta do FOIL on this.
X squared.
FOIL or x squared plus 1 plus 1x plus 2x is plus 3x plus 2. So you understand where I got that? I did the O and I FOIL together.
Plus 6.
So you do FOIL.
Yeah, so x squared plus 1x plus 2x plus 2. All right? I just did it all in one step. I mean, for this part right here. That's this. Okay, so what do we have?
3x squared.
Minus 3x plus 2.
All right, before we close up this problem, let's see if we have, if there's any way that numerator can be factored. Gotta be real careful there. So I would check to see if x plus 2 is a factor.
Wait,
Can't we just like
I'm
do the?
confused on the beginning steps. How is x minus
No, is it?
3
It
minus
doesn't
2x?
have.
So it's 2x times x, 2x squared, 2x times negative 3 minus 6x.
Yeah.
All right, and then these three terms come
Then what
from,
about the bottom?
oh, that's just from getting my common denominator, right?
Straight B.
Just like over here, my common denominator is 6x. My common denominator, these are relatively prime, so it's just the two multiplied together is the most common denominator.
So we don't actually have to like make it one number, and you can do like What about x?
Right, and I still want to see if this can be factored.
X
This may be
minus
done
1
here.
times x minus 2.
Okay, so I'm gonna go 3x, and I know these both have to be negative. How do I know these both have to be negative?
Oh, because there's a negative.
Right.
Well,
1 and 2, 1 and 2, 1 and 2.
The 1 and 2 works.
Well, we need to, the 2's not gonna matter here. Okay, this is, it's, because, assuming I've done everything right here, all right, it may be factorable, but I don't need to look at the answer in the book, but I think we're done here. Even though this can be factored, nothing cancels out. There's no point to that, okay? But do check. Let me double check that we got it right. So we're not gonna worry, that's gonna be our final answer, but you have to check and see if, you do have to check and see if the factoring can occur. I'm gonna double check to make sure we didn't make a mistake. Okay. Wonder what problem that was.
How does that look?
2x plus
How do you go from here?
2x, where did I get that one? Man, where did I get that from? Oh yeah, we got it right. That's right. That's it. Okay, so that's the final answer. Okay, here we go. What's your LCD here?
X plus 1 times x.
Okay, so we got x plus 2 over x. Now, this is a subtraction problem, so it's going to be a little more complicated. Times what?
Times x.
Over x, right? Okay. Minus, let's separate this
X
5 over x. And I'm going to multiply by what?
X plus 1 over x plus 1.
Good.
Why did you do
Now-
x plus 1 on that side, but not x plus 1 on the
Because I've already got an x plus 1. I'm trying to get both denominators to be the same. This would be like if this was 4 and this was 5. This is 4 plus 1. So what's the least common denominator? 4 times 5.
So wouldn't that make it uneven?
They're the same.
Minus.
I'm trying to get them
Still
to be the
1.
same.
X plus 20
Like,
right?
yeah, I
Turn
know that.
the LCD.
20 and
They're the
20 is
same.
the equal to 1.
Now, before we go further,
Like, I have to get the same.
Oliver, it is the same thing. But it is the same.
that's
It's
the
still
whole
1.
point of doing multiply by 1. I'm not changing the value of that fraction. I'm not changing the value of this fraction. I'm just getting the denominator I want. If it was an equation, I would have to do that.
Right, so
Okay, now listen, before I go further,
negative 20.
I want to, now watch what I'm going to do here, look. Before I go further, watch friends, I've got x times x plus 2 over x times x plus 1. Now, I'm going to say plus negative 5 times x plus 1. I've got to make sure the subtraction is going to get carried through to everything it needs to. Is that a bothersome step? I changed this to an addition sign, and I gave the negative to the 5, and now that 5 will distribute through and make sure everything that's supposed to get subtracted gets subtracted. So, this is going to be what? I've got my denominator I want now.
Wait, can we cancel out the x plus 1 on the right side?
No, because that would just defeat what we just did. We got it in there so that we could actually put them together. Now, I see kids do that. That's just like a rat in a maze when you do that. You put it in there. No, it's a good question because they see that on tests. People will get the right denominator and then they'll cancel what they just put in there. Right? So there's an instinct that tells you, oh, cancel that. No, you can put that in there so that you can put these two fractions together. Okay? So good question. All right. So x squared plus 2x. And then here we go, right? Minus 5x minus 5. Right? Everybody okay with that?
Yeah.
Now I have x squared minus 3x minus 5. Now let's leave this alone for a second. Now I think I could factor this, but I can't factor in a way that's going to cancel anything out here.
So you can just leave
So
it.
we're going to leave it like that. But do check, right? See if x plus 1 is a factor. We know x is a factor, right? Why is x not a factor of the numerator?
Because it's on 5.
The 5 doesn't have an x, right? All right, we ready? Last page finally?
Yes.
Okay.
Still got another thing.
Oh, still another on that page?
No, that was.
And we have another. We'll have to do like one of them now.
It's like two.
No, I gotta show you, if I don't show you these, we're gonna be done in about 15 minutes for your work. I know, we're gonna get it done in 6 minutes. Now, let's leave this alone, but before I do anything, whenever you see this, remember this right here? When I see this, if these are opposite, did I skip one?
Yeah.
I did?
Yeah.
I did this one first. I'm gonna factor out a -1 from here. And that'll be 2x minus y. Do I see that? Now, this negative can be thought of as a negative factor. I can put it up here if I wanted to, right? Still makes it a negative fraction. So these two negatives are going to make this a positive. Right?
Wait, where did the negative?
I factored out a negative from each of these
Wait, so
terms.
our denominators are relatively the same, right?
Not now. So when you see things like this, where they look very similar, but their signs are off, factor on -1 and see if they're just opposites. If I have a negative factor in either the numerator or denominator, I can think of that negative times a negative, so it makes a plus. So, for example, here's what that would look like with numbers. 3/4 minus 5 over -4, right? So I can make this what? I can make this 3/4 minus -5 over 4, right? So negative plus, right? Now, the good
So you
news
should
about
change
that,
the sign
What's
in
that?
the
Can you
numerator.
scroll it just a little bit?
Yeah, that's what I thought, because if you factor a negative in the bottom, would you have to do the same?
no,
Can you scroll?
no, there's no reason why I would have to do
No, I
that.
mean like because of the sign, the negative sign. So you have to do that for the numerator too.
Like I did here?
No, like, you know, on the other problems.
Yeah, I could have.
You change the
I
sign.
could have, but I realized I had a factor of -1 and then I would have a like denominator, so you could go ahead and do that. It would all come out in the wash anyways. But it would have come out the same. You could have done that, right? But you would have had to have realized at some point that these two are actually the same if you factor out a -1 and then,
So where did the -1 come from?
well, it's like saying if I have -8, I can make that -1 times 8, right? I mean, I can just change. If I have 7 minus 3, I can change that if I factor out a -1, right?
So is the
-1 times 3 minus 7, right? They both equal what? What is 7 minus 3?
Is the y negative?
It was negative when I factored out,
Oh, you said
it was positive when I factored out a -1. It made you change both of their signs so that I have the same denominator. It was a cheap way for me to get to the same denominator. Now what? I got the same denominator, so just put all your numerators together.
2x plus 4 over 2x minus y.
Please don't cancel out the 2x, it's not a factor, right? Okay, all right, getting there. All right,
Wait, can you go back down?
yeah, I'll come, yeah.
Oh, we still recording?
Yes, we're still recording. You haven't done anything embarrassing, don't worry. Okay. All right. Now, let's go ahead and do what you said, Heidi, just so you know. Let's go ahead and change this to plus, and I'm going to change the signs of both of those, okay?
Yeah, but in the other one, it wouldn't come out to the same thing.
I know, because I
That's
didn't,
weird.
it would have come out if I could have done it both ways, right? So if I did that way, it would have come out. But I just chose not to. But most of the time, you're going to do that. Okay, so don't let that dissuade you from that instinct. If you want to do that all the time, do it. So what's this going to be when I do this negative to both of these? Plus 6, right? Well, it changes both. The negative applies to everything in the numerator. So if this is positive, it becomes negative. If this is negative, it becomes positive, right? Negative, negative. Now, how does this factor?
Would that be y plus 3, y minus 3?
Difference of 2 squares, right? What's my LCD? Now I got enough to get my LCD.
Oh,
Y equals 3 squared.
And this is y plus 3, y minus 3, right? Right? So this is the LCD actually, so I don't need to do anything to that one. What am I going to do to this one over here?
Multiply
Y minus
by
3.
y minus 3 over y minus 3.
Right. Plus negative 2y plus 6 over y plus 3, y minus 3. Okay. So, I've got my denominator I want now. Let me erase this and I'll just move over here. I'll stop after this problem because I think it's gone on long enough, but what I will do is I'll add the last 2 problems. I'm going to keep going so you guys can start the homework because I've gone on too long. But I want you to be real quiet while I'm working, okay?
Yes, sir.
So, okay, but I do want to have those in the notes, and I don't want to start this, so I'm going to have to do a whole new broadcast. So what is this? This is going to be, my denominator is what I want, right? Y plus 3, y minus 3.
Yeah.
What's that? What's the numerator?
Oh, y squared minus 3y?
Y squared minus 3y, and then with this, minus 2y plus 6. Okay? So with this, y squared minus 5y plus 6. Now, before we put this one to rest, is this factorable?
Yeah.
Y minus 3, y minus 2. See, we're in some pretty serious algebra here, right?
Can you cancel them?
Yes. They're factors, right? So cancel right there. Final answer is what? Okay. All right. So I've gone on long enough. So if you want to start the homework, I'll let you go ahead and start. Like I said, I need to be perfectly quiet.
What is that, y plus 3?
Thank you. Yeah, y plus 3. Thank you. Okay. Listen, I need you to be quiet because I'm going to just act like nobody's in the room. I want to give you some time to start the homework. Feel free to take notes on these.
Can you get it back?
You can come back. I gotta get this done, or I'll have a pause in it. Okay. All right. So this next problem, my LCD is 2y squared. I'm going to rewrite the problem before I deal with the LCD by changing this to adding. It's going to be negative y minus 7 over 2y. I've got to bring my LCD in, so I'm going to multiply this fraction by 2 over 2, and this fraction by y over y, and that will give me 2y minus 14 minus y squared minus 7y, all that over 2y squared. You're going to have negative y squared minus 5y minus 14, and there's no common factors there, so that one's finished. This last problem, my denominators, I've got to practice this one denominator over here, so I'll just rewrite the problem before I do that and actually make that a minus 2 over plus minus 2 over a plus 2. going to factor that denominator, factor the -2, it's sum to 1, a plus 2, a minus 1, so my LCD here is a plus 2, a minus 1, okay? And then, so that means this fraction, I've got to bring in an a plus 2. And this fraction, I've got to bring in an a minus 1. And I don't need to do anything to that last fraction because it's already got the common denominator, so I need to distribute in the numerator. And now I've got everything I need to in the denominator, so it's a minus 1, a plus 2. This is a squared plus 2a minus 2a plus 2 plus 3a minus 6. I've got a 3a here, so a squared plus 3a and then minus 6. And let's see if that's factorable. Factors of -6, it's sum to 3, I don't think it is. So I think we're done on that. And that is the end of the broadcast.